Hello. As promised from our last video clip, when we looked at the rebound impact for an object that is hitting a wall at angle 90 degrees, now we're going to look at an object that is impacting a wall such as this at an angle where this is the normal to the wall, that is the angle, that's the initial velocity with which the ball or the object is hitting the wall, and then it bounces back because we assume that that is an elastic impact, so which means the initial velocity is the same as the final velocity. Okay, so this angle is the same. So before, what we studied was that if what's going at angle 90 degrees, we have a plus u as initial velocity, and we have minus u as the final velocity. What's going to change here is that we're going to have to resolve this u along the horizontal axis, which means we need to find the x component of this velocity u plus the x component of this velocity v. If we can do that, then we can actually find the change in velocity. So let's do just that. So basically, again, as usual, we use a different pen. Our change in velocity is v minus u. Our v in this case is going to be minus u because it's the same as this velocity, but it's coming back in a different direction. So it's going to be minus u minus u. But in this case, the change in velocity that we're going to be looking at is actually going to be the x component of v and the x component of u. So if we look at that, then we're going to end up with minus v cos theta minus u cos theta. And since we already said that v is the same as u, we then say that this is the same as minus u cos theta minus u cos theta, which then gives us minus 2u cos of theta. Now, this is the change in velocity. What about the change in momentum? For the same mass of ball, velocity changing. Okay. So we then write this as whatever we've got here for delta v will be m times minus 2u cos theta, and we are left with minus 2m u cos of theta. So you will recall that when it was 90 degrees, okay, we only have delta p to be minus 2mu. When the ball hits the wall at 90 degrees. And this is how we generalize the solution for a ball or an object that is impacting a wall at an angle. If we are then looking for the impact force, as we've already done before, our force of impact will be rate of change of momentum, which would then be minus 2mu cos theta, okay, over t. And that is how we simplified an expression like that. If we put a figure to it, if we say the mass is 1 kg, u is 1 meters per second, we can then put all the information. Say this angle is 30 degrees. We can then put all of these values in there. Our change in momentum will then be 2 times 1 times 1 times cos of 30 minus. And if you see all of this happen in a time 1 second, that will be 1 second. So we can then resolve that and find what this solution is. And that's a generalized solution for a ball that is hitting a wall at an angle, at an oblique angle, and then we can find the change in velocity, we can find the change in momentum, and we can also find the force of impact. And that's how we resolve a scenario like this.